All right, everybody. So today we're going to look at conversion factors, and I'm going to show you a way to do math, and it's going to be very helpful for the imperial section. And so feet and inches and yards and all of that. It's also going to be amazingly easy when you get to chemistry, which is what we're doing after Christmas. So bear with me. Before we do that, I need to know, we need to do a little bit of pre-work because frankly, we've avoided fractions so far completely. So grab some loose leaf. Here we go. Oh, good, shows up. All right, a few things, even before we go to fractions. I'm going to give you some questions and you can do them. So hey, 5 times 1. Tristan, what's the answer? It's 5. And I'm not even going to insult you by asking the other ones. 17 times 1 is 17. Oops. And 1 times 10 is 10. Okay, what if, so whether it's the 1 first or the other number, 1 times anything is that value. And that also applies to variables. So b times 1 is just plain old b, or 1c is equal to c. So that's the first thing we know. I'm going to mess around my camera a little bit. It's the first thing we have to know. So 1 times anything doesn't change the value. Next thing we need to know. Hey, Tristan, what's 5 divided by 5?
1.
Yes. Not sure if you're getting his audio, but it's 1. And if we go 15 divided by 15, it's also 1. 2,486 divided by 2,486 is still 1. So anything divided by itself is 1. And again, this also works if you have variables. So a divided by a is just 1. The a's disappear. Basically, they cancel out, but you want to be careful and don't say cancel out and disappear. They cancel out to 1. And even if you had something like, I don't know, the opposite side divided by the opposite side, it doesn't matter what that stands for, the answer is still going to be 1. So when, for example, we're doing something and we end up with an answer, this is going to be important in this section, of meters divided by meters, that's just going to cancel out to 1, and my units are going to disappear. That's what we're trying to do in this section, is get the units to disappear. Or if we have grams divided by grams, it's going to go to 1 and my units disappear. All right, so anything divided by itself is 1. The last thing we need to know is how to multiply a fraction. Hold on. There we go. Tristan, you got any ideas? No, multiplication is, sorry, for those not hearing his audio, sorry about the voice that just popped in there. You don't. Multiplication is so much easier than addition and subtraction. We don't need a common denominator. All we do is you multiply across top, multiply across the bottom. That's it. So 3 times 5 is 50, and 4 times 6 is 24. That's it. That's all we need to worry about. So if we have to do any multiplication like that, that's what's going to happen. And then we can either reduce down or whatever the instructions are, maybe we just divide it out. I don't know, it doesn't matter. So one more time, let's try 12 out of 40 times 16. Uh-oh, I made big numbers out of 3. Again, when you're multiplying, across the top, across the bottom. So 12 times 16 is 192 over 40 times 3 is going to be 120. And for now, that's all we need to worry about. So that's the introductory stuff. And I know I'm kind of going over it, something that's really simple, but trust me. So anything times 1 doesn't change our value. Anything divided by exactly the same thing is 1. And that goes back to 1 times something, doesn't change our value. And multiplying across for fractions, across top, across the bottom, and there's your answer. And then depending on the question, it'll tell you how you should simplify it. All right, we're done with that. Let's go to our booklet. Now, these are some, okay, basically really silly equations and things that I just thought of the other day when I made this up. And I suspect just common sense, you know how to do all these questions. But I want to get you used to using conversion factors. So these things up here, trying to think which column. Equivalence, Q-U-A. Trying to think what they're called. Well, I'm going to call it an equivalent today because it's equal. So 12 items is 1 dozen. There are two shoes in 1 pair. Okay, 8 hot dogs in a package, and randomly 1 chicken is 3.4 kilograms for this equation. A conversion factor is taking this and making it into a fraction. So 12 items that's a conversion factor. So all I did was put the 12 on the top, the dozen on the bottom. When you're doing these, you have to carry the words with you. It's completely useless if you lose the units. And I said for each of them, there's 2 different conversion factors. And it's just the flip of it. So if this is the first one, the other one is 1 dozen. Is 12 items. So every single equivalent, like this, has, where's my camera? 2 fractions you can make out of it. So the next one would be 2 shoes, 1 pair, 1 pair, 2 shoes. Maybe pause the camera right now, and why don't you just do the other 2? All right, I'm hoping you did that. Let's just finish it up. And you, right now, if you don't know what to do with them, you're not supposed to. It's completely okay. All right, so we got 8 hot dogs in 1 package. 1 package. The nice part is once you start doing these, you're going to get comfortable with it. And it's not like you're going to have to write out the conversion factors. You'll be able to look at the equivalent and just know which way to write it. And then we finally got 1 chicken. .4 kilograms and 3.4 kilograms for 1 chicken. I guess if we use the mathy stuff in the beginning of the year, these would all be considered rates. because a rate is two items being compared and the units don't match. All right, let's use these. So here's our steps. Determine what you're starting with, usually something units and numbers, and what you want to end up with. All right, so number one, how many hot dogs are there in 3 packages? So 3 packages is where I'm starting. That's my given. And I write that out, and I have to, you want to include the unit. All right, always. Now, the nice part with using conversion factors is no matter what you multiply. So I'm going to multiply by my conversion factor. Now, I need the ones on hot dogs. So it's these guys. And it says, find the equality that has the units for both the start and finish. Well, okay, so I got hot dogs and packages. And I'm in packages, and I want to go to hot dogs. So it's one of these two. Write out the 2 conversion factors, done. Multiply by the conversion factor that has the end units on the top and the start units on the bottom. So I want to end up in hot dogs because it's how many hot dogs. And I'm starting with packages. So I want to write 8 hot dogs for 1 package. And we are going to multiply these 2 fractions. But wait. Hey, Tristan, that first part, that 3 packages doesn't look like a fraction. Do you know of a way to make it better?
Put over 1.
Yes. And put over 1, and away we go. So I do the math first. 3 times 8 is 24. And 1 times 1 is just like 1. But, you know, let's be legit. But this is where the magic happens. Oh, I don't want to do this. I'm going to do it. It's going to look really weird, and then I'll show you how we cancel out. So if we bring along our units, it's going to say packages and hot dogs. And on the bottom, it's going to have packages. Three packages. There's the 3. Times 8 is 24. Don't scare me. Okay. And I brought along all the words, but if you see right here, I've got package divided by package. That disappears. So essentially my answer is 24 hot dogs. Now, you never write that part. All you do is there's a package on the top, there's a package on the bottom. It disappears, and we have hot dogs left, which is the unit we were looking for. And I know that feels complicated, but you gotta trust me, this will make your life so much easier, especially when we get into the feet in unit, the whole imperial system, and also in chemistry when we're doing molecular masses and things like that. All right, let's try one more. Oh, we're gonna actually try a whole bunch more. How many dozen apples are there in 52 apples? So I start with whatever the question gives me. I have 52 apples. And I might as well just put it over 1 because I know I'm going to be doing this fraction thing. And I know every single time I'm going to multiply. And then I look for the how many. And it's talking about dozens. So that means I can choose 12 items per dozen or a dozen per 12 items. And the thing says over here, the n units on the top. So I want to end up with dozens, so I'm going to put 1 dozen over. Now, I'm going to cheat here. It says items, but I'm talking about apples. So now when I multiply across, 52 times 1 is 52, and 1 times 12 is 12. My apples cancel out, and I'm left with dozens. And that's what I wanted it. I wanted to convert it into dozens. And then I take my handy dandy calculator and I go 52 divided by 12. And oh, okay, my calculator is goofy. It gives me fractions. I don't want that. Yep. I should have picked a better number, but that's okay. So you get 4.3. Now, hey, Tristan, how do I, instead of writing all those threes, do you know of a shortcut? Fair enough. I wasn't going there, but you could round to 4.3. You can also do a bar over top to show it's the repeating.
Oh, okay.
Oh, well, there you go. And there we go. Again, I'm sure most of you, and first of all, I'm going to say I'm sorry that I didn't leave a whole lot more room for this, for you guys to do it. I'm sure you can figure this out yourself, but practice it using these conversion factors. If you get good at it, I have friends in physics that didn't understand physics at all, but they could do conversion factors, and they were getting like 80s and 90s on assignments just by knowing how to convert units back and forth. So at this point, I'm going to pause the video, and I would like you to pause the video too. And I want you to do some questions, and then we'll come back together and see how it went. All right, and we're back. So let's see how you did. We have 12 chickens, so this is where we're starting. That's what we write first. 12 chicken. And I'm going to multiply because I always do. And we want to know weight. So I guess I should have had kilograms in there. So if I'm going to be choosing from this list, if I put one chicken for 3.4 kilograms, well, that's not going to work because then my units, nothing is canceling out. I'm going to have chicken squared, and that does not make any sense, right? You always want to do the ones that you want to end up with at the end or at the top. So I want to end up in kilograms. So I want 3.4 kilograms per chicken. And I'm going to make that one. You can probably do that as your first step all the time. So then I multiply 12 times 3.4, 40.8. And my chickens cancel out, and I'm left with kilograms. And my answer makes sense. If every chicken weighs 3.4 kilograms, 12 of them, yep, that sounds like about 40 kilograms. Even if you said there's just 3, that would give you at least 36 kilograms. All right, my bad. It's basically the same question, except this time you have 15 chickens. So over 1 times, and I know maybe one way to look at it is I need to get rid of chicken. So chicken needs to go on the bottom. So that means the 3.4 goes on the top. Oh, I like that. Maybe that's a better way to look at it. Is frankly, you're getting rid of units. So 15 times 3.4 is 51 kilograms of chicken. 51 kilograms. Shouldn't say of chicken because chicken disappears. Chicken disappears. All right. Now, how many chicken are there in 50 kilograms? So this time I'm starting out with 50 kilograms over 1 times. You know what? I'm liking the new plan. I just want to figure out how to get rid of the kilograms and convert it into chickens. So I know if kilograms is up there, I need kilograms, oopsies, down here. Yeah, I think it's easier. 3.4, and then it's got to be 1 chicken up here. My kilograms are going to cancel out. So I know I've got stuff lined up right. So 50 on the top, 50 times 1, 1 times 3.4. That's still on the bottom. And I'm going to put chicken, even though it looks silly. So then we go 50 divided by 3.4. And I get 14.7 chicken. Now, this last one is kind of crazy. I think we have several things to convert, but I'm going to see how this works. So I'm starting with 3 dozen. And I know that's going to be a 1. And I'm going to multiply. If I go up to the top and look at my conversion factors, there's only one of them that has dozen in it. And there's only one that has dozen on the bottom. And it's got 12 items. But that isn't doing anything about shoes. And I started with pairs, so pairs better disappear. 2 shoes for 1 pair. I think there was a shoes and pairs up there. Let's see. Yep. Oh, I guess I could have said 12 dozen pair. That would have been even better. Because now we can see the dozens disappear, the pairs disappear, and we're left with 3 times 12 times 2. And that's going to give me 72. Now, okay, it got a little messed up because the word items in there. That should have said pairs. But that's okay. No, it shouldn't. No, it shouldn't. I'm just going to stop trying to make this better. 72 shoes. This works better when we are not using bizarre things like dozens of pairs of shoes. And
Change the item to shoes.
Should I change that to shoes? No, because then it's not going to cancel out. I'll get you squared.
Okay.
The dozens disappeared, the pairs disappeared. Or maybe it's just 12 and forget it. It's 12 in 1 dozen. Don't use a unit at all. Let's take a look. If I skip, remember we did apples up here? And there was items and I said change to apples. What if we just, there, look at how pretty that is. I think I like that. When we, who's taking that out? Oh, well, you guys are all clever. And this is the first time I've tried this worksheet. So maybe that apples needed to be there. I'll get back to you on that one. But we're going to call that the end of this video tomorrow. No, on Friday. We're going to take this and start applying it to the imperial system. So the imperial system is used in construction, I think more than anything. Inches, foots, yards, and miles. In Saskatchewan, if you go out in the country, the miles is important because our province was, initially surveyed out in square miles. So that's why if you get directions to somebody's house and you have a car that's only got kilometers on it or something, it gets a little bit weird because every fence line is basically half a mile. But we're going to leave that cool stuff for tomorrow. We're going to stop our share and wish everybody a great day.